For section 7.3, we're going to talk about triangle similarity using angle, angle, side, 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 and side, angle, side. So the first one is angle, angle similarity. And if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So just going on two of the angle measures, if they're the same in both shapes, then we can say that the triangle is similar. Explain why the triangles are similar and write a similarity statement. So looking at this here, since these two lines are parallel, then angle P is congruent to angle R. So this angle and this angle are the same because they are alternate interior angles. They're on the inside of the parallel lines and they're on alternate sides of that transversal, so on the opposite sides of those lines. So those two are congruent, as well as T and S. So angle P is congruent to angle R, and angle T is congruent to angle S. And that shows us that two angles are congruent in this triangle, and the two triangles, so that these two triangles are then similar. So we can say triangle PQT is similar to triangle, and we have to name them the same way. So R goes with the P, Q is in the middle, so Q again, and then S. And that is because of the angle similarity theorem. Then we're going to talk about side, side, side similarity. If three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. And then side, angle, side. If two sides of one triangle are proportional to two sides of another triangle and their included angle, so it has to be the angle in between those two sides, are congruent, then the triangles are similar. So for example 2, we have to verify that these triangles are similar. We have to prove that the ratio to the sides are the same for all three sides. So I'm going to look at the statement up here. PQ is the first and PR is the first in that. So PQ is 4 and PR is 6. So 4 over 6 is the same as 2/3. Then I'm going to do QR and RS. So QR is also 4 and RS is 6. So that would reduce to 2/3 as well. And then the last sides, PR on the outside and PS on the other side. So PR is 6 and PS is 9. And those can be divided by 3. So I get 2/3. So that verifies that the ratio to all three sides is the same between the two triangles, so that we can say triangle PQR is similar to triangle PRS, and that is because of side, side, side similarity, because we only talked about the three sides. Now for part B here, we have to look at JKL and JMN. So because these two triangles are in the same triangle here, they share angle J. So angle J, of course, if it's in both triangles, is going to be congruent. So now we need to take a look at the side lengths because we want to talk about the sides that are adjacent to that angle. So we have to look at JK, which is 2. And then from J to M is the side of the big triangle, so that would be a 6 because 4 and 2 together make 6. That would reduce to 1/3. And then on the other side, we have to do JL, which would be 3. And then J to N would be 9. And 3 over 9 is 1/3. So the two sides are proportional and the angle in the middle is the same. So we can say triangle JKL is similar to triangle JMN. MN, and that's because of the side angle side congruence. For example 3, we need to explain why triangle ABC is similar to triangle DBE and then find the length of BE. So this angle right now is vertical angles, and vertical angles are the same. So we know that angle B is the same. And we need to compare the two sides. So BC goes with BE, and we don't know what BE is yet. So we have BC is 54 over X, but we do know AB, which is the first two, is 36, and DB is the first two in the other one, and that's 54. So explain why these are similar. So if they're similar, these two ratios would be equivalent. So we need to cross multiply. So we need to do 54 times 54, and that is 2,916. And then we divide by what's across from the variable, which would be 36. And when I do that, I get 81. So the length of BE is 81. And then for our last example, the photo is what that's supposed to say, shows a gable roof. AC is parallel to FG. So the bottom and then the line going across the top, and they're marked there with the little arrows, so those are parallel. We need to use similar triangles to prove that triangle ABC is similar to FBG, and then find BF to the nearest tenth of a foot. So we need to find that shorter side of that top triangle. So we know that angle BFG, let me find right, here we go. So this angle here is going to be the same as BAC. Because of the parallel lines, they cut that same line, and they're parallel, so they cut at the same angle, so those two angles would be the same. The same thing goes over here for G and C. Those two angles would be the same as well. And then since this is all inside of one larger triangle, the little triangles inside of the larger one, angle B is the same. So we're not going to work with this pair over here, but we do know that they're the same. So two angles out of the triangles are congruent. So therefore, the two triangles are the same based on, or similar, not the same, similar, based on angle, because we proved two angles in each triangle were congruent. We can actually prove three, but we only need the two. So triangle ABC, a triangle ABC is similar to triangle FBG because of the angle similarity. Now we need to find BF. So let me erase my marks here. So BF is right here. We don't know what that is. We do know that this bottom here is 6.5, and it is similar to the bottom here, which is 24. So now we need to set up the ratio of the sides. So I did the smaller triangle on the top, so our X value is going to go on the top for the smaller triangle. And then this right here is X plus 17. We don't know what the whole length is because we don't know what X is. So X plus 17. So now I have to do 6.5 times X plus 17. And that is going to equal 24 times X when we cross multiply. So now I have to distribute here. So I'm going to have 6.5X plus 6.5 times 17 is going to be 110.5, and that equals 24x. Then I'm going to subtract 6.5x. 110.5 equals 17.5x, and then I have to divide by 17.5. So when I do that, x is going to equal about 6.3. That's what my calculator says. So this length of BF is approximately 6.3, and these are feet.